Welcome back, class. In the last section, we talked about how to calculate this thing that we call the derivative. So for some function, f of x, we talked about how to calculate f prime of 2, or f prime of 4, or f prime of minus 3, or whatever. All of these sorts of things. In this section, we're going to talk about one way of interpreting these, which is to connect them to this idea of a tangent line, which we've talked about a little bit before. So, if I take some graph, like this, okay, at every point on this graph, there's what we'd call a tangent line. And so here, there's a tangent line that looks like this. Over here, there's a tangent line, and it looks like that, roughly speaking. Here, there's a tangent line, and it looks like that, roughly speaking. And the whole idea of tangent lines is that the tangent line has the same slope as the graph at that point. And I want to note the tangent line depends on two things. It depends on the graph, so whatever function this happens to be, but it also depends on the point. So any question where I ask you to calculate a tangent line, I'm going to have to give you a point on the graph, so the red point, the blue point, the purple point, something like that, and the function. And then that will determine a tangent line. So in this example, if this happens to be the x-coordinate 1, this is the x-coordinate 3, this is the x-coordinate 4, here's the point. The slope of this line is f prime of 1. So the x-coordinate of this point, the input of this point, the derivative exactly tells me the slope of this tangent line. Likewise, this blue line has slope f prime of 3. Okay. And this purple line has slope f prime of 4. And so today, we're going to talk about how to find the equations of these tangent lines, and then we're going to talk about how to think about the derivative in terms of the slopes of the tangent lines. Okay, so I'm going to start by having us look at the function f of x equals x squared minus 6x plus 10. And this function I have designed so that its graph looks exactly like this graph here. It's a parabola pointed up whose vertex happens to be at 3. And so I can go ahead and reproduce this graph, roughly speaking, here. And what I want to do before we go much further is to find the equations of these three tangent lines that I drew before. So let's do the red one first. So that one is going to be this line. Okay. So I want to find the equation of this line. Okay. So first of all, it is a good idea to find the coordinates of this point. So its x-coordinate is 1. Okay. And so what's the y-coordinate of this point? Well, the y-coordinate of this point is going to be f of 1. Okay. And f of 1 is 1 minus 6 plus 10. That sounds like plus 5. Okay. And note again, this is f of 1. The y-coordinate of this point has nothing to do with derivatives. It is just the y-coordinate here of this point, which I just get as the output of the function corresponding to the input 1 here. But the slope of this line is going to be given by f prime of 1. Okay. And so I need to calculate this f prime of 1 exactly in the way that I did in the previous videos. So namely, I'm going to calculate, okay, I've got the point 1, 5, and then the point 1 plus h, comma, and I've got to figure out what goes there. Okay, so that's going to be f of 1 plus h. Is 1 plus h squared minus 6 times 1 plus h plus 10. Is 1 plus 2h plus h squared minus 6h plus 10. So this is going to be h squared minus 4h plus 5. Okay, so that is our 2 points that I need to use to find this derivative. So I can find what I have called before the average rate of change, which is just the slope between these 2 points. So that's going to be h squared minus 4h plus 5 minus 5 divided by 1 plus h minus 1, which is just h. Okay, and so this is going to be h squared minus 4h over h, which is h times h minus 4 over h, which is h minus 4. And so then my f prime of 1 is the limit as h goes to 0 of that h minus 4, which is, in fact, minus 4. Okay. So the slope of this red line that I'm looking at is minus 4. And that, in fact, gives me plenty of information to calculate the equation of this line, because I have a point and I have a slope. So the equation of the tangent line now has to look like y equals minus 4x plus b. Okay. But key fact, the tangent line at 1, 5 has 1, 5 on it. Okay. So this is something we're going to end up using a lot. And so what that justifies is me plugging in 1, 5 here. And so when I do that, I'll get 5 is equal to minus 4 plus b. And so the red tangent line now has equation y equals minus 4x plus 9. Now, just to check that everything worked out the way it was supposed to, I'm going to go ahead and pull up this graph in Desmos. So here is our graph of f of x. This is just a graph of x squared minus 6x plus 10. Now, I'm going to superimpose on top of this the graph of the thing we found for the tangent line, y equals minus 4x plus 9. And I've here put all the coordinate axes in here so you can see, for example, that this really is touching the graph at the point 1, 5. But more importantly, what I want to draw your attention to is how at the point 1, 5, this line just kisses the graph and seems to go in exactly the same direction as the parabola at that point. That's the essence of what we're doing this week. We're trying to make sure we understand how to make lines like this for the various kinds of graphs that we're interested in. Let's do the same thing now for the line that we previously called the blue line. So namely, let's find the equation of this tangent line. Okay, so this point here is 3, comma, and then f of 3. And f of 3 is 9 minus 18 plus 10, which is 1. Okay. So this point is 3, 1. Now, from the graph that I've drawn, you probably have a really good guess as to what the equation of this line is. And the reason for that is because this line appears to be horizontal. Let's go ahead and check that it really works out that way if I actually calculate it using this formula. So, the slope of this line, the slope of the blue line, is going to be f prime of 3. Okay. And so to calculate f prime of 3, we're going to find our 2 points. So 3, 1, and then our bumped point, which is just a point a little bit to the right. So 3 plus h, comma, and then I've got to figure out what this is going to be. So f of 3 plus h is going to be 3 plus h squared minus 6 times 3 plus h plus 10, which is 9 plus 6h plus h squared minus 18 minus 6h plus 10. Okay, so there's an h squared. Let's see, plus 6h minus 6h, so there's no h term. And then 9 minus 18 plus 10 is plus 1. And so this perturbed point is 3 plus h, comma, h squared plus 1. That lets me go ahead and find my average rate of change between these 2 points, which is going to be h squared plus 1 minus 1 divided by 3 plus h minus 3, which is just h. Okay, and so this is going to be h squared over h, which is just h. So now that I've calculated that, my f prime of 3, it's the limit as h goes to 0 of just that h, which is in fact 0. And so this says exactly what I thought from looking at the graph, which is that the slope of the tangent line here at 3 should be equal to 0. That means this line is horizontal, which means that the equation of the tangent line should be exactly y equals 1. Again, we can look at this in the graph, and we can see now the blue horizontal line there kissing the graph there at 3, 1. At that particular point, 3, 1, the graph of the parabola is not actually going anywhere. It's staying horizontal, which is why this tangent line here is horizontal. Let's do one more example, namely let's find the equation of this purple tangent line. Okay. So first of all, let's go ahead and find the coordinates of this point. So the x-coordinate here is 4. What's the y-coordinate then? It is f of 4, which is 4 squared minus 24 plus 10. Okay, so that is 16 minus 24 is minus 8 plus 10 is plus 2. So this point is 4, 2. Let's go ahead and find the equation of the tangent line to this graph here at 4, 2. So we write down our point 4, 2. We move that point a smidge to the right, so we replace the input 4 with the input 4 plus h. Then calculate f of 4 plus h, which is 4 plus h squared minus 6 times 4 plus h plus 10. 16 plus 8h plus h squared minus 24 minus 6h plus 10. So there's an h squared, plus 2h plus 2. So our y-coordinate here is h squared plus 2h plus 2. So our average rate of change then is h squared plus 2h plus 2 minus 2 divided by 4 plus h minus 4, which is h. It's h squared plus 2h over h. You can factor out an h. Cancel the h's. Get h plus 2. Okay. And so now we can go directly to calculating the slope of our line. So the slope of our tangent line, the slope of the purple line here in this graph, that is f prime of 4, which is the limit as h goes to 0 of this h plus 2 here. Okay. And that limit is 2. Okay. And so my purple line, it has slope 2, so its equation looks like y equals 2x plus b. But it passes through 4, 2, so I can use that. Okay, so that is 2 is equal to 2 times 4 plus b. So that says b is minus 6. And so that tells me that the equation of my purple tangent line is y equals 2x minus 6. Again, I can check this by showing this to you in a graph. And voila, here we go. We have our purple line, which we can see as tangent to the graph at the point 4, 2. Now, I want to point out we could tell a lot, even if we went back to our very first sketch of this graph, about what was going to turn out to be true about f prime of 1, f prime of 3, and f prime of 4. Okay. And I'll note I wrote this graph before I even gave you an equation for this function. I just showed you a graph. But I can tell the slope of the red line is negative because of the direction it slants. I can tell the slope of the blue line is 0 because it's flat. And I can tell the slope of the purple line is positive because it slants this direction. Okay. And so what that means is just by looking at this graph, I could tell you, hey, the derivative here at 1 is negative, the derivative here at 3 is 0, and the derivative here at 4 is positive. Okay. Or, even if you don't want to think about the lines here, you can think the slope of the graph here is definitely negative, the slope of the graph here is 0, and the slope of the graph here is positive. These things I can tell by looking at the graph. I want to point out that we can use this idea the other way around. So here I've given you a graph of a function. I've given you no equation for the function, but you can have the graph. And I have two questions for you. The first is, what's g of 3? And the second is, what's g prime of 3? Let's do g of 3 first. So when I go to find g of 3, I want to look at the input 3 on the x-axis, and then I want to follow that up to the corresponding point on the graph. That point you should end up with, if you go to 3 here on the input axis and follow it up, is this point up here, 3, 6. And so that says that if you take the input 3, the output that you get out is 6. How would I go about finding g prime of 3? Well, g prime of 3, remember, is going to be the slope of the tangent line at this point. So I can probably tell by looking at this graph just as is that that slope is negative. But I can go ahead and grab my ruler and I can draw in the tangent line. Note, in this case, I've shown the tangent line in dots The only reason I've shown the tangent line here in dots is because usually in the packet I show the tangent line in dots or dashes just to distinguish it from the graph that we're talking about. But g prime of 3, this is the slope of the tangent line. And I can draw in the tangent line like this. And so this g prime of 3, it is this slope. Let's try and figure out the slope of this line. How are we going to do that? Probably we're going to find 2 points on it. One of those points we've already talked about. It's 3, 6. And so what am I going to do? I'm going to scan back and forth on this line with my eyes until I stumble upon a point like this one, where I can see, aha, this point I can read off. That point is 4, 4. Both of these points are on my tangent line, and so I can calculate the slope of the tangent line. It is 4 minus 6 divided by 4 minus 3, which happens to be minus 2. Okay. And so the slope of the tangent line here is minus 2. But that, by definition, is g prime of 3. And so g prime of 3 is minus 2, g of 3 is 6. I'm going to wrap up this video here for now. In the next video, we'll talk about a couple more examples of calculating the equation of the tangent line in the fashion that we've done, and of using graphs to find the derivative. But that's all for now. I'll see you next time.